Okay, well today what we're going to be doing is we're going to be talking about Chapter 3, Section 3, which is solving inequalities using multiplication and division. Okay, that is our objective essentially. Okay, our academic standard is A1.2.5. Okay, the first property we're going to talk about is multiplication property of inequality. Okay, so what this is saying, and really it's the same thing as an equal sign, we just have these inequality symbols that are inside everything. It just says if we have any real numbers a, b, and c, and if c is greater than 0, which just means that for this section that c is positive, that when we take a is greater than b and we multiply ac to both sides, it still holds true. So for example, a nice easy one, 2 is greater than 1. When I multiply by a positive 3 to both sides, well, it doesn't change my answer. It's still, excuse me, can't do that, 6 is greater than 3. Okay, so 6 is greater than 3. And then the other side of it would just be, again, if we were to say like 3 is less than 6, and we were to multiply by 4 to both sides, a positive 4, okay, that would still hold true, that we would have the same values. So this one would be 12 is less than 24. That's true as well. Now down here we start talking about negatives. Now negatives changes things. It actually flips the signs. So here if we would have said like 4 is greater than 3, now when we multiply by a negative, for instance 4 times a negative 2 is greater than 3 times a negative 2. So up here we multiply both sides by a positive. Down here we're multiplying both sides by a negative. Okay, negative to both sides. That makes negative 8 and that makes negative 6. Well, in this case, actually, negative 8 is less than negative 6. It forces it to flip the sign. So you want to note that off to the side of your notes that anytime you multiply by a negative to both sides, you must flip the sign. Okay, multiply to both sides by a negative. Well, let's look at some examples in this case. Okay, the first one is multiplying by a positive. So obviously we're not going to flip the sign, but let's see how it works. When we have x over 3, to get rid of the 3, we have to multiply by 3. So just like before, even though there's a negative in this problem, we are only multiplying by a positive to both sides. So no flipping of the sign. Okay, the 3's cancel. X is still less than negative 6. So we put negative 6 here, put an open circle, we put some labels here. Okay, and then here negative 7 and negative 8. And because it's saying we want to shade this way, we're going to shade our number line this way. Now let's check our work. Pick a number down here. So let's just pick something that's divisible by 3, so negative 9 divided by 3. That needs to be less than negative 2. Well, that makes negative 3. Is that less than negative 2? Yeah, that checks out. Okay, because negative 3 is less than negative 2. So I just picked negative 9, which would have been right here, which is in our shaded area. Okay. Well, let's look at one that is multiplying by a negative. So in this case, we have the negative 3x over 4 is greater than 3. It's not because this is negative, it's because what we have to do is we need to multiply by the reciprocal, okay, which means that we are going to have to flip the sign when we get to the other side because we're multiplying both sides by the negative 4/3. So negative on this side now, negative on that side. So we must flip the signs. Well, when we write this down to finish it up, the 4's cancels, the 3's cancels, it becomes an x. But now the sign is less than. Here the 3's cancel, leaving you with negative 4. So again, we write our labels -4, put an open circle, put some labels here. Again, it needs to be increasing there, decreasing over here. And it's saying shade to the left. And again, if you want to verify, we're going to pick a point. Pick a point that's less than -4. Okay, so maybe pick -8 because we know that's divisible by 4. So 4 and 8 cancel, becoming 1 and 2, and that needs to be greater than -3. Well, 3 and 2 make 6, but negative makes it positive. Is 6 greater than 3? Yeah, that one's true, so that checks out. So notice how that works, that even though when you multiply both sides by a negative, when you flip the sign, it still checks out in the original. Now, you always go back into the original, which is exactly the same sign. And just because you took a -3/4 times a -8, you don't flip the sign. Only when you do it to both sides. Okay, when you multiply the both sides by a negative, then you flip the sign. Okay, both problem 1 and example 2 have a part B. I want you to go ahead and do the checks now, and then when you come into class, we'll go over those part B together and see what you got. Okay, so let's look at the division property. Really the same thing. Okay, for any real numbers A, B, and C, if up here C is positive, greater than 0, so positive, when we divide, nothing changes. Everything's the same. So you can divide and nothing will be affected. So 4 is greater than 2, but 4 over 2 and 2 over 2, nothing changes. You get 2 is still greater than 1. Okay, the sign's always the same. But down here, we have the negative. C is less than 0. So when we do this one, when you say like 8 is greater than 4, and when we divide by, let's say, 2, -2, since we're dividing both sides by -2, the sign flips and you get -4 is less than -2, which is correct. -4 is farther to the left than -2. Okay, so let's check out a problem on this set. And when we look at this problem, we have -9y is less than 63. Okay, well, we got to divide by a -9 to solve for y. When we divide by a -9 to both sides, the sign flips. So y is greater than, well, 9 underneath the 63 is 7. One of them was negative, so it's a -7. So again, when we do our number line, we go a -7 in the middle. It's an open circle, increasing over here, decreasing over here. Okay, and it's saying letter, symbol, number, we should be shading this way. Okay, and we would check our work as always, which pick something easy, pick 0. Okay, that's greater than -7. Well, quick multiplication of 0 is 0. Is 0 less than 63? Yep, it is. So it checks out. So all you have to understand is that multiplying or dividing by a negative to both sides, it has to be you dividing to both sides makes it a flipped sign. Other than that, if it's positives, anything like that, you're keeping all the signs the same. Nothing changes with that. Okay, there's a part B for this one. I want you to go ahead and do that. I want to come in and see what your examples are like. Okay, if you have questions, go to Twitter, go to Edmodo, put a post up there, see if someone else can help you or I can help you. Okay, try to leave a lot of examples here for you to try on your own, so when you come in tomorrow, you have something to ask if you need it. If not, then you got it. That's awesome. Okay, we'll see you tomorrow.